I'm not going to waste my time much on it. But let's just brush over it so that we can just go and do better things. Now, what the text? A text is the collection of a well-defined object. You know this already. Well-defined objects. If you are talking about well-defined objects, it seems that if you put an atom together, that atom has a common property or common features. Then you say that it's well-defined. Maybe they have a common purpose. Now, like we have the example of a set, would be the set of a category or mathematical set. These are some of the examples of sets. For the first one, it's being used for dinner because all the elements within the set are used for dinner. We have the fork, we have the knife, and so on and so forth. They are all used for dinner. So we have grouped them for a purpose, that is dinner. So we call it a set. Now, if you look at the mathematical set, we have the elements inside. And their main purpose for construction. If you want to construct any geometrical figure, you can use it to construct it. So they are also called that. So you can give some example of a set and explain why they are sets. So you can give some of them. Now let's move on to notations of sets. You know almost all of them, so I won't waste my time here. So we have the element that the elements of a set are usually denoted by lowercase letters. So if you want to indicate any member of a set, you can just use the small letter to indicate it. But if you want to represent a set, use the capital letters. And then the element of a set will be enclosed in the curly bracket or set bracket. Now the symbol this belongs to or a member of or an element of a given set. So for instance, if A is an element of a set, small a is the element of a set A, then we can write it as A belongs to set A. A belongs to set A. The symbol, this symbol also. So the symbol, this symbol is also what? The negative of this. So that's not. So if you're having A is not a member of, or maybe A does not belong to, or A is not an element of a given set, then we use this symbol for that. Now we have the symbol for union when you are combining two or more sets without repetition. So that symbol is A union B. It means you're putting together all the elements in both A and B. But you won't repeat those who belong to both of them. You write only one. That's the meaning of that symbol. Then you have intersection symbol, which is also for selecting or grouping all elements that belong to both sets or all the sets concerned. So just select them, and then we group them as a set. So that's why intersection. So that's a symbol. So we have A intersection B. Select all the elements in both A and B. Now you have another one called a subset. Now if you say a subset, it will be having two or more sets, but one becomes the biggest among them, whereby all the elements of other sets are found inside. So we are saying that A is a subset of B. Means all the elements in A are found in B. Then you can also have it like this. Now the symbol gets turned in the opposite way. So I will call this a superset. Superset, we have subset and superset. Now we have B is a superset of A, or B contains A. B is a superset of A. Super means the superior. So we have superset of A. Now if B contains A, we can say A contained in B, or we say that B is the superset of A. Now B is the superset of A is equivalent to A is a subset of B. They all mean the same thing. They all mean the same thing. So we have subset of equal sets. Now we have superset of equal sets. We have the empty set or the null set at this. That is said without an element. Now, before we move on, let's also take note of these standard symbols that you may use, or you may even see them as you read maybe set, or even mathematical books, you may even see them. And one of them is just n, like this. Another double one like this. And it represents non-negative integers, including 0. So on the other hand, you can see that this one represents a whole number, positive whole number. From 0 going to positive infinity. So whenever I see maybe a set belongs to this, then we are talking about it. Non-negative integers, including 0. Now, whenever I see the Z form like this, it gets a set of integers, all integers. This time, it belongs both negative, positive, and then 0. All of them. You can represent that by the symbol like Z. Now we also have the Q, also being represented by rational numbers, all rational numbers. And R is also for all real numbers, and C is for set of all complex numbers. So as we move along, we may be meeting them. So you should know them by hand or by heart. And it's not only this course, we may be even meeting them somewhere. They are the standard ones. Did anybody have any question? Is it okay now?
Yes, sir.
You can all hear me. Eh?
Yes, sir.
Yeah, we can hear you, sir.
Okay, that's good. So
I
let's
hear you.
set representations. Set representations. Now you can represent set in 5 main forms. 5 main forms. Now, first one, either you can just list down the members. Example is, let's say, a set of 1, 2, 3. It's a set. I will know the members. So we are just listing down the members. Now you can also, example is 1, 3, 6, 9, 12, 15, and so on and so forth. But before we move on, can somebody tell me the name of this set? What's the property of the set, this set? First one, the set of 1, 2, 3. Is the set of what? Let's be fast, eh? Is a set of what?
Set of natural numbers or positive integers without zeros.
A set of
Natural
or
numbers.
positive integers
Yes.
without 0. That's all. Okay, you have done something. Anybody? Oh, let's hurry up, please. Now, even though the set of positive integers excluding 0 or set of natural numbers, but it's not all natural numbers that we have in the ETA. Or not all the positive integers that we have them here. And we are taking part of it. Therefore, we can say that a set
No,
of natural
sir.
numbers
Yeah.
may be less than 4. Are you okay? Or a set of natural numbers between 1 and 3.
I understand.
Good. Now, wait, what can you say about this set?
Yes, sir.
This set is what? 3, 6, 9, 12, 15.
Multiples of 3.
The set of multiples of 3. You haven't finished. Concrete.
Less than 16.
Less than.
Okay. The last one is the set of alphabet. Eh? from A to what? D. Okay. Now we can then list down the members of the set. That's one way we can represent a set. We can also describe a set by using a set builder notation. We can say that by a description of some attributes or characteristics of an element of the set. This method is more general and involves a description of the set property. Now, example is I can get A equal to the set of X is such that. Now here we can use the bar here, or can use the column. You can just use the column here like this. Either you use the bar or use the column, it's the same thing. So we call it X is said that X is an odd prime number. Or A equal to X said that, yeah, so I'm not using the column here. It's an odd prime number. So the two are the same. Now this notation is called the set builder notation. Whenever you're using X is said that X is 30, you're using a set builder notation. It's also another way of describing or representing. Now example is A is the set of X that N is positive integer greater than 100. Yeah, so we have example A is the set of X is said that X is positive integer greater than 100. So if you are having the set builder notation, whenever you want to go into the set A set, you might also write down the member before you can use it to do whatever you want to use it. This is read as the set of all X is a positive integer greater than 100. So B, we have a set of X is said that X is a complex number. X is a complex number. I hope you know complex numbers. Do you know complex numbers?
Sir, please, not really for me.
What?
It's not really. I just know that they are numbers which in the form A plus BI, and where A and B are real numbers, but the I don't really understand.
Okay. Okay. So you have the real numbers, you have the complex numbers. Are you okay? Now, you may be, let's see, do you have calculators?
Yes, sir.
So another way of also representing set is also describe the set by a recursive formula. That means if we have let S not equal to 2, then no S not. Then no X1 equal to 1. Then from this, you cannot find the rest of the members. You can say that if I start from 0, if I is 0, this one I'll get S1. Or here I'm saying that yi is greater or equal to 1. So when X is 1, I is 1, I'll get here X2. Now X2 is equal to X1 plus X0. But I know all the values of X now, which is 2, X1, which is 1. So when I put it, I'll get my X2. When I let I equal to 2, I'll get X3. And here become X2, here become X1. So I know my X2, I know my X1. You put them there, you get my X3. So you can just go on and on to find all the elements of that set. So you can say that by recursive formula, then you can get the members of the set. So example is A is a set of Xi. Now I is greater or equal to 1. So Xi, I is greater or equal to 1. So this I can list all the members from 1 going. Because when X is 1, I is what? 1. So when X is 2, you get 2, and so you get 1 up to positive infinity. That's how you can also describe a set. So that you list down the members, use the set builder notation. You can also even go by the recursive formula to come out with all the members of the set. You can also describe a set by using this formula we call the piecewise function. So we can also describe a set by its characteristic function. That is mu A of X equals, now we have, if X belongs to A, now the answer is 1. Now, if X does not belong to A, the answer is 0. So you can just use this one to come out with all the members of the set A. That's also another way. And lastly, we can also just come up with the members of the set or describe the set by an operation on some other set. By some of the operations. So let's say you can have maybe intersection or the union and so on and so forth. They can describe the members of the set. Any question? So these are the 5 main ways you can just describe a set or represent a set. So let's try the following. Describe the following set by listing its members. 2, describe the following set by giving the characteristic property. So let's see how you're going to describe the set I. Okay, it's about the set. Describe the member, listen to the members. So what are the members of this given set? You are doing it to, I've said try it. So let's come out. What are the members?
Okay, sir.
Yes.
So the first one have members like 2, 1, 0.
Are you sure?
No, sorry, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Okay. So that's the members of that given set. Now let me give you just 5 minutes to finish all of them, I to 5. Now for the first one, the 5 minutes. Everybody, 5 minutes. Finish all this. List down all the members of the set. The first, please. I. What are they?
We have April, June. We have April, June, September, and November.
April, June, September, and November.
So we have X is such that X is equal to April, June, September, and November.
Okay, so we have only 4 months, which ends or 30 days.
Yes, sir.
Okay. What about I? X is said that X is a composite and X is between 20. X from 20 and the what? 70. Between 20 or from 20 up to, let's say, or less than 70. Yeah, between 20 and then 70. But 20 is inclusive. 20 is inclusive. 70 is exclusive. What are the members? What are the members, please? I.
So it's an empty set.
Empty set? No, please.
There is no
No,
member.
please. No, please. No, please.
Sir, please, the members of that set are actually many, but because composite sets, this composite numbers should be numbers that have more than 2 factors.
Yes.
So it means they are not prime numbers.
Yeah.
So 20 to 70, we are looking at numbers that have more than 2
So
factors.
come out, the members. Come out. We start from the first one.
Okay. Okay, so 20 itself is part. 21.
Okay.
22. 24.
Move on.
Okay. 24, 25,
Okay.
26.
So when the members are so many that you can't get rid of them, you can read only few. When you know the last member, then you bring that, get 3 dots, and then you write the last number there. Are you okay? So you can have it like maybe
Okay, sir.
20. 21, maybe 22. They can bring a dot here, comma here, they bring 3 dots. Because it's a final set. Are you okay? So the last one will be what? Are you okay? So you can just write it something like this, and then you're okay. Okay. Ivan. Ivan. A equal to the sort of X is said that then as if Y belongs to the set of 0, 1, 2, 3, and X is equal to Y key. What are the members? I'm sure that now you know the meaning of it. You understand it. Because we have done it under logic, quantifiers. So A equal to X is said that then exist Y. Y belongs to the set of 0, 1, 2, 3, and X equal to Y key. So what are the members? Before you can come up with the member, you can understand the set. So what does it mean? Before I come up with the members, what does it mean? What set are we talking about? Yes, Oh, don't let it waste our time here.
All right, so it says X is equal to Y cube. And we are looking for X. So I think all the members of Y will cube them. So we'll have 0, 1, 8, and 27.
Are you sure? A equal to X is said that there exists Y. But Y is the member of what? 0, 1, 2, 3. And X equal to Y key. So you find a value of X. Whereby when you go to the Y bar, there is a number. When a number that will give this equation, X will be equal to Y key. So you can get started in evaluating. Are you okay? You can still go, because if you get one number, then fine. If you do not get any number, you get empty set. So let's go to Y. So when Y is, let's say, let me give X 0. Let me give X 0. Now when X is 0, Y cube will also be at 0. So we have Y equal to X. So 0 become one of the members. I get my point. Now when X is 1, when X is 1, Y cube will also be 1. So it means we have 0 and 1. They are also members. Now when X is 2, 2 cube will be 8. So 2 is out. And when X is 3, when Y is 3, okay. Let's say when Y is 3, it also do what? 27, which will be out. We want to find a situation whereby both X and Y are equal. So to me, that set now would be what? The set of 0 and 1. The set of 0 and 1. Now I'm leaving the name for you to go and try it. And then the rest of them, the example 2 for the time factor. So example 2 is very just simple one. They start with the set given by this one. So when you can also try that one. So let's move on to types of sets. Types of sets. Now, first of all, we are going to talk about finite sets. As the name implies, it means you know all the members of a set. You know all of them. You can count them from the first to the end. So any set whose members are known, we call that set a finite set. So example is the set of 1, 2, 3, 5. We know all of them. So they're finite. The set of what? The alphabet, the English alphabet. You know all of them. Now the last one is what? X is said that X is a factor of 100. This way you can list all of them, all the factors of 100. So you know all of them. Now when listing the elements of a finite set with many members, if the members are just many, as I told you previously, we need not to list all of them. You can list the first two, the first few, then bring the comma and trade dots, and then write the last one. As we have done it for you, like a set of A equals a set of 1, 2, 3, 4, 5. Now we have trade dots here. Then write the last member, which is 50. So you can discard this set of the set of what? Natural numbers up to 50. So we know all the members. Then we call it a finite set. Now we have 4, 8, 12, 15, up to 100. So this one too, we see that we have now, after getting the 15, now we brought trade dots. Now we write the last member. So someone should describe this set for me. It's what? It's about what? B is the set of what? B is the set of yes, B is the set of it. Let's hurry up. What can you say about this set?
Multiples of 4 less than
Less than or
101.
equal to 100.
Multiple of 4.
Yeah, it's a multiples of less than or equal to 100.
Let's not go to what? 100.
Equal to 100. Or multiples of 4 between 2 and 101.
Okay, let's take this through. Okay, so that is where we know all the members, so we call the finite set. We have the infinite. The opposite of finite is infinite. When you set, it said that we don't know all the members. We don't know the last member. Then that set now becomes an infinite. So if the set is not finite, then it was infinite. So a set is infinite if it is not finite, or when all its members are not known. Example, the set of all real numbers. Now nobody can just mention all the real numbers that you have. No, you can't do that. So it is an infinite set. The points on a line. If you draw a line that you want to just come out with the point, the number of points that you have on the line, it becomes very what? Impossible. So it is what? Infinite. So this way, if later you also written down the members of the infinite set, you can just write the first few and then bring the trade dots. If you don't know the end of it, then just leave it like that. So example is this. Now, at times, if you know that going up to maybe positive infinity, you can just write the positive infinity as the last maybe member. Since infinity is not a number, but represent any huge number, if you don't know that number. So that also makes it an infinite. Okay. Now let's go to universal set. In many discussions on the certain sets, all the concerned sets are considered to be subsets of one particular set or bigger set. This set is called the universal set. That the name implies universal. So to me, we are having about 2, 3, 4 sets. And when you put all of them together, they also form sets. And even with maybe even having additional even members inside. That will become the biggest among the rest of the sets. We call that the universal set. So universal set is often designated by the script letter U. Or at times some of those make it even X. But this is normally what we normally use, U. Universal set is not unique and it may change from one discussion to another. Why are we saying this? Why it's not unique? Why? Why is the universal set is not unique? Yes, Oh. Not to me, it depends upon the particular set that you are considering. If I'm talking about the set of maybe real numbers, then real number become my universal set. We are talking about the set of integers. Now the integers will have some members which are integers, but not all that. I do not have all the sets that contain all the elements of integers. The integer become what? The universal set. For times I can even give you the given set contain a lot of members, and I give you some other sets whose members are found inside that universal that set. Then you call it also universal set. So because we don't have one particular set that we call the universal, that's why we are saying that it is not unique. Now, example, if you have the set A equals the set of 0, 2, 7, B the set of 3, 5, 6, and C the set of 1, 8, 9, 10, then the universal set can be taken as the set of U equal to the set of 0 up to what? 0, 1, 2, 3, 12. That doesn't mean that whatever I'm talking about any given set, this now become my universal set. That's why we are saying it's not unique. It depends upon the set we are talking about. Now let's go to power set. If you don't have a question, power set. Now the set of all subsets of a set A is called the power set of A. Now whenever you're having a set, any set, you can form some subsets because a set consists of subsets. So if you're having a set A, all the possible subsets that we can form from the members of set A is called the power set. But you see, every set is a subset of a set. And then also, a null set or empty set is also subset of every set. So whenever you are forming some subset of a given set, you must include the null set, that the empty set. And you must also include the set A set. So the power set of A is denoted by P of A. So whenever I say P of A, then we are talking about power set. And then we are talking about the number of subsets that you can get from A, by P of A. Hence, P of A is equal to the set of X. It said that X is subset of or subset of what A. Meaning all the subsets that we can get from A. Then it becomes our power set. The power set of A is also denoted sometimes by 2A. 2A. Now, we can also have a formula that we can also enable us to also find the number of subsets that we have. And that's why it's given by P of A equals 2 power n. So if you're having a given set, you want to know the number of subsets you can form from that a given set, then by using this formula, you can get that number. Where n will be the number of elements within that set A. So whenever you want to know the number of subsets that you can form from a given set, now you can apply this formula to help you to know that number. So from there, you can then move on to make a list down or form your P of A. So example, if A equal to the set of A, B. Now the elements of the set A is what? A and B. So it means our n is 2. We have 2 elements, therefore our n is 2. So if I want to find the number of subsets that I can get, it will become 2 power n. Where n is 2, it will become 2 power 2 and get 4. It means I can form 4 subsets. Don't forget, including the empty set and set A set. That will give my power set of A. Good. So we have P of A. The part of the A now is the set of now the set of A, set of B, and the set A set. So the set of A, B. So I think we got it before, and we're having the 4 elements. So remember, we have 1, 2, 3, 4. So that's our P of A. Now P of null set is equal to the set of null set. P of null set is equal to the set of null set. So if you have P of null set or power set of null set, we are saying it's equal to the set of null set. Why? Any explanation to that? Any explanation to this? Power set of null set is the set of null set.
Sir,
Yes.
because any number raised to the power 0 is 1. So it makes the null set to have only 1 power set.
One subset, okay. And that subset will be what?
Yes. Also 0.
Come again. Tell me what? You started nicely, so don't fall it. You started nicely. So what will be that subset? Because we are now letting us know that the number of power sets will be 1, because any number with the power 0 is what? 1. So because the null set, the number of elements in the null set is 0. Therefore, your n is 0, so 2 power 0 is 1. And therefore, our power set now of 0 is a power set of null set is the set of null set. Why? Yes. Because we have always said that every set is subset to itself. Are you okay? And then every set include set, the power set includes a subset and the set itself. Now this time we are having only one subset. It means that it will be the same set, because by all means, that's why we won't miss it. Because every set is subset to itself. So therefore, null set is also subset to the null set. As if we are now going to get the number of power sets, it gets 1, then it means that one becomes our what? a subset. Hence, P of null set or power set of null set is the set of null set. So are you okay?
Yes.
Yeah. Let's try to get it because we are going gradually. So we are saying the P of null, okay, so it is only one subset since n is 0. Now, example 1. Given A equal the set of, for all x belongs to the set of all prime numbers, and x is less than 9. Find power set of A. Given A equal the set of, for all x, you have done this also, you know it. For all x belongs to the set of all prime numbers, and x is less than 9. So it means we are going to a set of prime numbers or all prime numbers. Then we are going to pick those which are less than 9. That will now become our
So-
set of A.
We'll have 1, 3, 5, 7.
Is 1 a prime number?
Okay, so we have 3, 5, and 7.
Yes. You should be careful. Prime number, composite numbers, and so on and so forth. So we are talking about odd one. So we become 2, 5, no, 3, 5, 7. Therefore, our n is 3. So don't be confused when I'm using the quantifiers, because we did it last week. Don't be confused with that then. So therefore, we have n is 3, hence the number of power sets will be 2 power 3, which is 8. So we are now going to get 8 subsets that you can get from the set of 3, 5, 7. So you can start even forming them. So P of A, power set of A now becomes the set of null set. As we said, every null set is what? Subset to every set. So we are the set of 3, first number, the set of 5, 7. So 1, 1, 1. They can get combined them, 3, 5. So we have that 3, 7. We have that. We have 5, 7. And then the set is 8. So we are 3, 5, 7. So when we count them, get 8 subsets. Therefore, the number of power sets is 8. Now, example 2. Find power set. Yes, Bella. I saw your hand, please. Bella, I saw your hand. Do you want to ask a question?
Yes, sir.
Yes, ask.
Sir, please, can you hear me now?
Yeah, I can hear you.
Okay. So I was saying that, so would this conclusion be right for me if I say, if you have to find the power set of a particular set, it simply means that you are finding the number of subsets that we can get from that set. Is
Yes.
that it?
Yes.
Okay. All right. Thank
Including
you, sir.
0, no, the empty set and the set is set.
Okay. All right.
That's all. That's
Thank
the
you,
power
sir.
set.
Okay.
The name is confusing,
This is the first time I am hearing it actually.
Yeah. But don't forget that you are now at the university. Some of the things that you know even at the SS, when you can they change the name. But they mean the same thing. Are you again?
Oh, okay. That's okay, sir.
Yeah, because you are not growing. You are not at the university, so you are not a small man.
Not at all.
So that's the power set. So power set needs the number of subsets that you have, or subset that we can get from a given set, the power set. You put all of them in the set. Don't forget, it is a power set. So that's why it's also a set. So not just a mere coming out with a subset that we can get from a set, but we put all of them into a set. That's what a power set.
Okay. Okay.
Good. Example 2. As we move along at the last date, if you have a question, you can just come out with your question and we go discuss it. Find the power set of B, given that B is equal to the set of for all y, then exists x. Y is the set of factors of 12, and x is an even. Find the power set of B, given that B equal to the set of for all y, there exists x. Y is the set of factors of 12, and x is even. So find the power set of B. So all we're saying that go and find your y. Y is the factors of the set of factors of 12. So you can list all of them. So then among this one, we have some of them which are even. That there exists x. Why x is even. So among all the factors of 12, now come out the even numbers. That will give you a set of B. So to the factors of 12 now will be the set of 1, 2, 3, 4, 6, and 12. So among them, you're going to get x. There exists x. That is even factors of 12. Now the B now become the set of 2, 4, 6, and 12. Therefore, our n, the number of elements in the set is 4. Hence, we cannot form our power set. So now that we know n, how many members do we have in the power set? How many subsets we can get from the power set? How many?
16, sir.
16. Called 2 power 4. So therefore, we have to form all of them. And you can check that. So that's all the 16 subsets, which are formed a given set we call a power set of B. I hope we all getting it. Do you have a lady among you?
Sir, no, not in this class.
Or you are all men?
Yes, sir. Boys,
Yes, sir.
boys.
Okay. The ladies, they like the business and go. Okay. Now, let me give also some time to also try this. So let's see, because we don't have much time to wait here. So let's try the first one and the second one. So I and I, 5 minutes. I and I, let's just take the 5 minutes to do that. Or let the 10 minutes is okay. I and I. Find the power set of A, given that I, you are the set there, you have I, you are the set there, and so on and so forth. So let's start. Okay, so now I. What are the members of A? Before
The
you can
members
get the power set, you must know the members. So what are the members of A?
It's only one member, which is 8.
There's only one member. What is that?
The number 8.
Are you sure that it's only one member?
It's 4 and
I
8.
got
Or it's multiples of x is multiple of 4. And x is between 2 and 12. So how many members?
I got 4
Members,
members.
4 members here.
I got 2.
It should be 2 members.
Sorry, 2 members. Sorry, 2
Yes,
members.
which are 4 and 8.
Yeah.
Yes.
So
Yes,
therefore,
sir.
we cannot form the power set for that. So if we are 2 members, then how many subsets are you going to get?
That'll be 4.
4
4
subsets. Yeah.
subsets.
That's all. You are doing well. I like you, eh? Okay, I. What are the members?
I
Please,
got
I has
4 members.
1, 2, 4, and 8.
Yes.
For all x. For all and x is the factors of 8. So either 1, 2, 4, and 8. So how many are they?
They are 4, sir.
4. So you can have 4. How many subsets for the power set?
16.
16. You can have form. Are you able to form them?
Yes, please.
Yeah.
That's good. You're doing well. Now, I think the third one, you can even do it. You can even do it. 4y, set 4y, there is x. Y is a positive odd integer less than 15. X is a factor of 9. So you can even do that one by the time factor. So let's move on. Now let's go to cardinality of a set. Cardinality of a set. Now here you want to know the number, the number of elements that you have in each set. That's what we call cardinality. Or we can really call the size of the set. The size. So the cardinality of a set is the number of elements in the given set. It defines the set, the size of that set, how large the set is. So you can even have like the magnitude of that set. Now the cardinality of a set is denoted by set A is denoted by this symbol. So that we are using the magnitude symbol or the module to also mean the cardinality because it talks about the size of the set. So we are now using the module sign for that cardinality. So whenever I see this symbol, and if you are talking about the set, that is what the number of elements in the set. At our SS level or maybe JSS level, we use just n. You just make it n of A to mean the same cardinality. But here we are using that module sign for that. So you have n of A the same, but how many elements do you have in A? The number of A. But here we are using that symbol for that. So don't forget that. Now, example, the cardinality of A equals the set of A, B, C, D is given by cardinality of A equals now 4. So we have that one and that 4 because we have 4 elements within. Examples. Find the cardinality of the following. Now, A, because this symbol, I won't read it for you. I want you to read it to me. Let me hear from you. I want to know if you can remember the meaning of this.
So
Yeah,
x is such that x is less than or equal to 3 and less than 20.
Come again,
And
please.
x,
Come again, please. Take
okay,
your time.
x is such that
Mhm.
x is greater than or equal to 3
Yes.
and x is less than 20,
Okay.
where x belongs to all integers.
Good. Good. That is integers. All integers. So now can you come up with the members? Can you come out with the members?
So we'll have from 4 to
Take your time.
19.
Open your eyes.
Sorry, from 3 to 19.
Okay. We have the inclusive, the 3 is part of it, but 20 is not part.
Yes.
Okay, so we have them
Yes.
here. So I play up to 19.
17.
What 17? It's 19.
Let's
And you
mention
have
the
17, yeah,
the cardinality.
Yeah, cardinality was 17. Good. It's 17. I. B equals the set of x is said that x is a multiple of 5 less than 50. So here too, should just list all of them for you to know how many you have. That will start from what 5 up to where?
Up to 45.
45. Good. So that
It's
will give us
9.
8. So to make another B, it was 8. These are it gets simple, it's not any big deal. Are you okay? This is I've made it very simple for you. Now see.
Sir,
Yes,
please, the I think we missed one of the
You
members.
missed one. Which one?
So please, the next slide.
Okay, you can come out of them, all of them. Let's come out. Start.
Okay, so that should be 5, 10, 15, 20, 25, 30, 35, 40, and 45.
It's
So
supposed
that
to be
should
9.
be a cardinality of 9.
Yeah,
Yes,
yeah,
please.
it's supposed to be 9. So we made what?
Miss 35.
35 is missing. Good. It means we have I. So this one should be 9. Thank you very much. Okay. Now I. What are the members? Members of C.
We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and 28.
Are you sure? For all x belongs to the set of integer less than 30, but x is even.
So we have even numbers. Okay, set of all integers. Okay, that means negative will come in. Doesn't mean negative integers will come in.
But if we are talking about even, we normally concern ourselves with the positive integers.
Okay, so it will start from 2, multiples of 2 to 28. So 2,
Okay.
4,
Okay.
yes.
So how many are there?
That should be 14.
Are
Sir.
there 14? Good. So that's the cardinality. So when you are dealing with the set, you see this modulo sign, we talk about the size of that set. And the size is the number of elements that you have in that set. We call the cardinality. Now let's move on to relationship between the sets. If no question. There are the subsets. Given two final sets x and y, if every element of x is an element of y, then the set x is a subset of y. That's why we know it already. We have been talking about that one. Now you have x is subset of y, or y is subset of x. So we can use this or that. Then we are not going to differentiate between the two later on. Now, for example, I given x equal the set of A, B, C, Y, P, Q, R, A, B, W, C, and Z, P, Q, R, A. Now this is why the dollar sign here and a C. Now, since all elements of the set X, you can get all of them inside Y. So you have A, B, C, you can get A, B, and C. So it means we can find all the elements of X inside Y. So you can say that X is subset of Y. So that's where we have X is subset of Y, but X is not subset of Z. Why? Why so? We have X is subset of Y, but not Z. Why? Yes,
sir, because all the members of X cannot be found in the set of Z,
So which one is missing?
B and C.
B.
No,
Good.
no,
So
Because if you don't have
B,
B
only
here,
B, only B.
X is not subset of Z. Good. Now, let A equal to, now X is between 3 and then X is greater than 3 and less than or equal to 12. Where the B, X said that X is positive integer less than 15. So you have, if you want to know that, you want to know the member, you have to list down the member. So you have the A now got the set of 4, 5, up to 12 here. And B the set of 1, 2, 3, up to 14. So can you say that A is subset of B? Or B is subset of A?
A is a subset of B.
It's B. Okay, what about B is subset of A? True or false?
It's false.
False. Good. Now, any set is subset to A set. We have seen this one under the what? Power set. Every set is subset of A set. So any set is subset of A set. That is, X is subset of X, and it's called the reflexive what? Property. Reflexive. Now you can even prove this one. So we are saying if X is any set, then X is subset of X. Then we can let X, let it belong to the set of A. Then X also belongs to the set of A. Because we have X, we have X, we have 2X here. So by the repetition of the statement, it means that X is subset of X. So if X is subset of A, if X belongs to the set of A, and the same X belongs to the set of A, that means the X is subset of X, or we can get, we have only A here. We can take only one, get a repetition. Therefore, we say that X is subset of what? X. Or any set is subset of A set. Now, if X is subset of Y, then it doesn't mean Y is also subset of X. Now you are having X is subset of Y. This doesn't mean that then Y must also be subset of X, as we saw it in the other previous examples. Now, if A is subset of B and B is subset of C, then we can have A is also subset of C. If A is subset of B and B is subset of C, then we have A is subset of C. I call this property sensitive property. I saw this one when we were doing the logic. Then we can use the syllogism law to prove that. So if A is subset of B and B is subset of C, you can see that A is automatically subset of C. We can also be written as A subset of B, B subset of C implies A is subset of C. And another say we call it transitive property. When it comes to logic, we can call it what? The syllogism. Syllogism. Now we can prove that transitivity. Let X belong to A. Then X belongs to A implies X belongs to B. Because we are saying that A is subset of B. So if we draw a Venn diagram, you could see that A will now be inside B. So if X belongs to A, then automatically X also belongs to B. That's what we want to tell you. So let X belong to A, then X belongs to A implies X belongs to B. That's for A is subset of B. Now implies X is also belongs to C, because B is also inside C. So like, let's say you have a pregnant woman boarding a car. No matter what, so far the mother is inside, the fetus or the baby is also inside automatically. That's what is happening here. So if X is subset of A, then if A is subset of B, that means whatever A has is also for B. And B is also belong to C. So to form that chain, we get like that. So it implies X is also subset of C. That for A is subset of C. Now, if A belongs to X belongs to A, then X belongs to C. Therefore, A also belongs to us, or subset of C. We can prove this one using a Venn diagram as we did under the logic. So you can even try it on your own. We found some of them here or over there. If you have a question, can ask. Now, if A is subset of B, but B is subset of A, or A is not equal to B, then A is proper set. Now, if A is subset of B, but B is not subset of A, here it is not, and B is not subset of A. When it happens in that way, that is A is not equal to B. When it happens in that way, it means we call this kind of subset a proper subset. So we say that A is a proper subset of B. And we know that one by this. So that's why I said we are not going to consider the difference between the subset and that it with the equal sign and the one with that equal sign. So if A is subset of B and B is not subset of A, then you say that A is a proper subset of B. And that's why we use only this one without bringing the equal sign and that. So from now going, so now we cannot differentiate between the two. Now try the following. So they prove this one. Given A equal the set of X, is said that X belongs to the set of real numbers and X squared minus 4X plus 3 equal to 0. B, X is said that X belongs to non or negative of integer, and X is between, or X is from 1 to 4. Prove that A is subset of B. So let me give you this one. Let me give you, let's say, 5 minutes to do that. 5 minutes to do this. It's almost 8.
My question is that when you are asked to prove, does it mean, how do you prove it? Does it mean you should use a Venn diagram, or how will you prove it?
If you can use the Venn diagram, you can use that Venn diagram. But this one, you don't need to try the Venn diagram. But just compare the two members to see. You know what if
Okay.
we are talking about subset, you know the subset. Okay, like
Yeah.
you got A to be 1 and 3. So we are the A is the set of 1 and 3. And we are the what? The B is the
Yes.
set of 1, 2, 3, 4. So you could see that A, all the members of A can be found in B. Therefore, A is a subset of B. That's all.
Okay.
This why I get a simple thing. Now let's go to another aspect, equal sets. Now, two or more sets are said to be equal if and only if they have the same elements. Two or more sets are said to be equal if and only if they have the same elements. For example, given A equal to the set of ABC and B equal to the set of ABC and C equal to the set of ACB. The three sets have the same elements, hence A equal to B and B equal to C, therefore A equal to C. So if A is equal to B, then use the equal sign to denote that A equal to B. So you have A equal to B. But why are we saying that A is equal to B? Why so? And B is equal to C. We are having A equal to the set of A, B, C, B equal to the set of A, B, C, and C equal to the set of A, C, B. But we are saying they are equal. Why? Yes,
Hello, sir.
Yes.
So I think that for two or more sets to be equal, it's not about the cardinality, but rather having the same elements.
Having the same distinct elements. Are you okay? So
Yes, sir. Okay.
if they have the same distinct element, then their cardinality are also equal, as you see. So we're having A is a set of A, B, C. When it comes to B, we have A, B, C. So this A and A, B, they are not distinct. Are you okay? So you take them as one. So the same as A, B, C. So the cardinality of B here is not 4, but rather 3. When we talk about the number of distinct elements that we have in a given set. So that's why I said the cardinality of B now is also equal to 3. Okay. So hence A equal to B and B equal to C implies A equal to C. Then because A equal to C, B also equal to A, then they have also the same cardinality. Because if the sets are equal, then the number of elements within each set are also the same. That's why the cardinality of A equal to B equal to C. That's what we call it 3. Not 4, because this one is out. Because they are not distinct. So take only one of them. Now let's see this one. Let's consider the sets below. Set A, the set of A, B, C. Set B, the set of A, B, and then C. We are saying that A is not equal to B. Explain the answer. Yes, Are they equal? Are they equal?
Okay, I think
Okay, sir.
B.
Yes,
Brother, please, you go.
Yeah,
Okay, I wanted to say that B has only 2 elements,
Yeah,
even though the first
no,
element, B has 2 elements,
okay, which
but the
are?
first element, which are A, B, and C.
So the
AB
set
is
of-
one element
The set of
now.
AB.
Yeah,
And
the
the
set of AB.
Okay, 2. And they
And
they
C.
also have that mean.
And A has 3 elements.
Good. So their cardinality are even not equal. Therefore, A is not equal to B. That's all. You agree?
Very well, sir.
Okay. So don't forget that we have
Sir,
A
can
here,
we also
B,
say
and C.
that
So they
the
say
set A,
they're equal. So you should be careful. Open your eyes. We have put A, B in just a set bracket, means that we are taking them as 1. So the set of A, B is 1. And it's these 2 elements and this 3 elements. Therefore, they are not equal. What about the set of 1 and the set of 1? Why? Why are they also not equal?
hello, sir.
Yes.
Yeah, so for the first example, let me try and link it with this one.
Okay.
So I was going to ask if we could say that the set A has a, or is a finite set, in as much as B is also a finite set,
Yes.
but B is a power set. Can we use that differentiation as well?
What power set? No, these are power set, please. Open your eyes with.
Okay, so I was trying to use because there's a set within the set.
No, no, no,
Just
it's
like
not a
it,
power
okay.
set. If they say
I get
within the
it.
set, that doesn't mean that it's a power set.
That's it. Thank you.
If B were to be a power set, then this one become one of them. We have also a set of C, not C alone. We have a set of C. Are you okay? And we have a set of A, B, and then bring also C in touch. And we have to, no. We have to get 4 elements, or so 4 subsets here. That all come together to form a power set. But this is not a
Yes,
power
sir.
set. But when you come here, see, the connector here is 1, are you okay? And this is also 1. But we are saying they are not equal. Why? Connector of a set of 1 is 1, and that of set of 1 is also 1. Why are they not equal? Or why are they not equal? Why? Yes.
So in a layman's understanding, maybe
Uh-huh.
I should say that because of the brackets.
What
So the
bracket?
first
No,
one has,
what bracket are you talking about?
as in the brackets that close the element. So
So,
the second one has 2.
so let's open your eyes with when you go to the first set, what the element in the first set?
It's 1.
It's 1. What is the element in the second set?
Set 1.
It's a set. Okay, so
Yeah.
1 and set, why are they the same?
They are not the same.
Are the
They are not
same.
the same.
Therefore, they are not equal. Are you all following now?
Yes, sir.
Good. So if you want to list down the elements here, it just set 1. But when you come here, this 1. So this is 1, this is set 1. The two are not equal. They are not the same. Hence, the set of 1 and the set of set 1 are not equal. Now, rule of equality of sets is reflexive, symmetric, and their transitive. That is described respectively as a set of X is equal to itself. We have seen this one already under the union type or the inverter or subset. So we are saying that A is what equal to itself. Therefore, we have A, the set of A is equal to the set of A because they have the same elements and the same cardinality. And when it happens that we call the reflexive. The reflexive. Now, the two sets X and Y, if X is equal to Y, then also Y is also equal to X. Now we call this one symmetric. Symmetric. So it means X is equal to Y and Y is also equal to X. Now last one, we have for any set X, Y, and Z. If X equal to Y and Y is equal to Z, we have seen this one the subset, whereby you can use the chain rule and so on and so forth. Then you can conclude that then X is also equal to Z. And we call that property of sensitive. Sensitive. When we talk about the equality of maybe the sets, then you think about this, all that. Now we cannot restate this. Now, based upon this equality law here, we cannot define equal sets nicely here. So we can only take this equality in terms of subset. That A, the set of A is equal to the set of B if and only if and only if A is subset of B and B is also subset of A. Again, two sets are said to be equal if and only if A is a subset of B and B is also subset of A. So when it happens that way, then we can say that A now is equal to B. So this is now how we cannot define it based upon that equality terms or the property. Any question? Any question?
Not for me, sir.
All right, then let's move on to the operation of this. The operation. And one of them is the union. The union. Now, given two sets A and B, A or B is the set of all elements either in 1 or I from the set of A, or I from the set of B, or I from both sets of A and as well as B. So when you are combining the two sets A and B, then we are saying that either the union means either you are getting the set of A or the set of B or both of them, the elements, when you combine them together. But this time, we don't want any repetition. So symbolically, we have A union B. A union B are this is a symbol for the union. Means that you are combining all the elements in A and B together to form another set. But no more repetition. So that's why we call the set of X is said that X belongs to A or X belongs to B. Okay, so example. If A equals the set of 5, 7, 8, B equals the set of 2, 7, 9, 10, 11, then A in B now becomes the set of 2, 5, 7, 8, 9, 10, 11. So we are combining all the elements here and here in just one set, but we did not repeat any number which belongs to both A and B. So we have 7 here, but we took only one, and so on and so forth. So if you look at the set of A B, you can see that it is either a member of what from A or from B or both. If A the set of X so that X is what integer, and X is greater than or equal to 3, and B the X is said that X is integer and X is greater than or equal to 8, then A B now will be the set of okay. So you see that A B now becomes the set of X is said that X belongs to integers and X is greater than or equal to 3. Why so? We are having A equal to the set of X is said that X belongs to the set of integers and X is greater than or equal to 3. We have B. X is said that X belongs to the set of integers and X is greater than or equal to 8. Then by combining them together, A B becomes X is said that X belongs to a set of integers and x is greater than or equal to 3. Why so? Where z denoted the set of integers? Why so? Yes, why so? Any explanation to that? Or you don't understand it?
The question again, please.
Or we have the question on the side. We are saying that the set of A is given by this. They are all, the x is what? X beyond the set of integers. And for A, x is greater than or equal to 3. And B, x beyond the set of integers. And x is greater than or equal to 8. But we are saying when you join them, when you combine them together, the union of A and B will also give the x is belongs to integers and x is greater than or equal to 3. And say why?
So what about the greater than or equal to 8? What,
Yeah, that's a
what
good
happened to
question.
that?
Maybe this
that
answer
one?
may be wrong. Or why?
Yeah, so the answer is wrong, I think.
The answer is what?
The answer is wrong.
It's wrong. Okay. What's supposed to be the correct answer?
It's supposed to be, the last part should be x is greater than or equal to 8.
So you combine the two.
Yes.
Okay. That's my view. Anybody?
Sir,
Yes.
I think that when we list the members of A and B, the members of A start from 3 to positive infinity.
Okay.
And the members of B start from 8. So it means that after listing subset of A, so that when we combine them, we don't necessarily list them if equal. We take one. So that's why x is greater than or equal to 3.
So the answer correct?
Yeah, it's correct.
Yes. Because here we're going to have repetition from 8 going. And don't forget 8 greater than 3 means now we are not going to pass through 8. And continue from 8 going. So there will be some repetition over there. And 8 will also, the B also start from 8 also going. So we are not going to have interaction between A and B from 8 going. And that's all of them also contain what? The A. So it means B is a subset of A. Hence, we take the bigger one. You agree now?
I get it now.
Yeah. So when the two meet, then you continue from that end. So you take a bigger set to be the union. That's why I made mention of something here. I say A, B is the set of all elements A. All elements either from the set of A or from the set of B or from both the set of A as well as B. So when you can be, we say we are taking all the set of A to be the union. Are you okay with that statement?
Yes, sir.
Because one is a subset of the other. So when it becomes that way, we take only one, the bigger set, to be the union. That's why I gave out this. Good. Now the union of the set, if you have it so many, it's not even two. We have 3, 4, 5. A1, A2, A3 up to AN is denoted by, now can you use this symbol for that? Like the summation, right? We are union here. We are summing from I, or we are finding the set I from what? 1 up to N. Where N will be the number of the sets that you have. So here we have 1 up to N. So we have N number of sets, and we are going to join them together, find the union of them. So we have start I from what? 1 to n. So we have A1. When I is 1, we have A1. When I is 2, we have A2, A3, up to AN. So when you see this symbol, to me, we are now just find the union of the sets. And it's equal to the set of X is that L belongs to AI for at least one set of AI. Now you have seen the similar one, it's the example that we saw over there. So let's the example, given A1 equal to the set of 1, 2, 5, 7, 9, A2 equal to the set of 2, 4, 6, 8, and A3 the set of 1, 3, 5. Now the union of I from 1 to 3, because we have 3 sets, we have n is 3. It's giving us AI equal to the set of X belongs to AI for at least the set of one set of I. Now by combine them together, to me, you are not combining the no overlapping here. That will give it 1, 2, 3, and the natural numbers up to 9 will be the union. We are putting all the elements together without repetition. If no question, let's move on. Properties of union. If A and B are two sets, then A is subset of, into bracket, A union B. A is a subset of, into bracket, A union B. Why? A is a subset of A union B. Why so? The property of union. Why so?
So because the elements of A automatically in the set A union B.
That's all. It's true. And the same thing like B is also sort of A union B, the same thing. Now what about A union universal equal to universal? A union the universal set equal to universal set. Why?
Because all the members of A can be found in the universal set.
That's all. That's all. So you can just prove them like this, and they go your way. So if A is in a set, then A union now set equal to A. These are some of the properties of the union. A union now set equal to A. Why? And A union A equal to A. So we have the proof also here. So A union now set equal to A, because now that there's nothing there, no element. So if you are now combine that one with element of A, then automatically you're not going to get only element of A. So therefore, A union now set is A. And A union A, the same A with the same element. If you join them together, you get the same A. If you have a question, can ask, we can close. It's now 8:29. You are done with. More than 2 hours. Any question, please?